So now we want to actually find some values for these binomial probabilities. Let me first mention some notation for binomial probability distributions. So B stands for the binomial probability distribution function, and we'll write this expression here. So X is our binomial random variable. The tilde there is just saying that random variable follows a binomial distribution with n is the total number of trials and p is the probability of success. So if you see that, that's what that means. So how do we find these probabilities? That is, how do we find p of x, the probability of x successes? Well, it's governed by this function here. N over x in parentheses like that, that is combinations of x from n. So that's the combinations function, or selections. And then we multiply by the probability of a success to the x power, and then 1 minus p is your probability of failure to the n minus x. So that's total of n trials minus x successes. So we won't evaluate using these formulas. The calculator will do that for us. So on the TI-84, if you want the probability of exactly x successes, you'll use a distribution function, binomial PDF. You have to put in your trials, your probability of success, and your x value. If you want less than or equal to x successes, you use binomial CDF. The C stands for cumulative. Again, you have to put in number of trials, probability, and your successes. These are under the second variables menu. That's the distribution function menu. So let me show you how to do some of these. So if n equals 10, so 10 trials, p equals 0.4, so probability of success is 0.4, calculate the following binomial probabilities. So they're telling you they're binomial. So, well, first of all, what is the probability distribution for x? So in other words, they want you to write this expression here. So x has a binomial distribution with 10 successes, and the probability of success, p there, is 0.4. So that's what they're wanting there. Probability that x equals 2, that's probability of 2 successes. So you go to your calculator, you press second variables, that takes you to the distribution function. And then binomial distribution, you press the arrow key and go down. Binomial PDF is letter A, binomial CDF is letter B. For just one number, we use PDF. So press enter, and then it asks you how many trials. So for us, 10 trials, enter. Our P was 0.4 here, and enter. And then X is equal to 2. Put that 2 in there, enter, and paste, and enter one more time. So 0.1209. These almost always will go to 4 decimal places. So 0.1209. So, and again, the way we did that was binom PDF. So binom PDF 10, 0.4, and 2. Probability x is no more than 5. So no more than 5. So x is not more than 5. If it's not more than 5, it's less than 5. So this is saying what's the probability that x is less than 5. Well, we can do equal probabilities or less than equal probabilities on the calculator. So we have to change this to a less than equal. If you're strictly less than 5, the next number down is 4 successes. So this is saying x is less than equal 4. So for this one, we're going to use binomial CDF. So we'll go to the calculator again, second variables, and now we're going to come down to CDF, which is option B. And our trials are still 10. Our p-value is still 0.4. And then our x, we are doing less than equal 4, so x is equal to 4. Enter, paste, enter. 6331. So 0.6331. How about what's the probability that x is greater than 3? So in symbols, it says probability x is greater than 3. We don't know how to do greater than probabilities on the calculator. We have to write this in terms of a less than equal. So we can use the complement probability, do 1 minus the complement. So 1 minus the probability. If you're not strictly greater than 3, the opposite of greater than is going to be less than equal. So x is less than equal 3. And then this one we can do on the calculator. Oh, let me write the command up here. This one was binomial, so binom CDF. And then 10, comma, 0.4, comma 5, 4, excuse me. 4 is our x. So this one we'll go ahead and plug into the calculator. So we want to do 1 minus, and now we go to the second variables menu, come down to CDF, binom CDF, 10 trials, still p is 0.4, but now our x value, we want x less than equal 3. So we just have to arrow down and change that x to a 3. And enter, paste, and notice I've got 1 minus out in front. I put that in before I went to the binomial distribution menu. And so 0.6177. And again, the way we got this was we did 1 minus binom CDF. And we had 10, comma, 0.4, comma 3. And then what's the probability that the number of successes is between 2 and 7? So this is asking what's the probability that x is between 2 and 7. So 2 less than x less than 7. So let's decide which values this is, because we have to write everything in terms of a less than equal, so we can use CDF here. So if you're strictly between 2 and 7, that's 3, 4, 5, or 6, those values. So we could do the probability that x is less than equal 6. So that's going to be 0, 1, 2, up to 6. And then we want to take away our 0, 1, 2, and that'll leave 3, 4, 5, 6. So minus probability x is less than equal 2. So that takes away 0, 1, 2. So it takes these guys out, and then you've just got 3 through 6. So each one of these is going to be a distribution menu. So this one, let's write out the command here first, and then we'll go. So this is binomial, so binom CDF, still 10 trials, p is 0.4, and we're summing up to 6, x equals 6. And then minus binom CDF again. Still 10 and 0.4 for n and p, but now x is 2. So let's go ahead and enter these into the calculator. So we want to go to second variables, come down to CDF, which is letter B. Still 10 and 0.4, but our x value now is 6. And we will paste that. And now before we hit enter, minus, and now we'll go to the variables menu again. And choice B again. but now x is 2. And enter and enter. So there's our CDF with 6 minus our CDF with 2. We press enter, 0.7779. So that shows several different examples of how you calculate these binomial probabilities.